Hey there, I thought I'd answer your question with a video because it's a lot easier to draw a picture than it is to write this out in words. Um, One of the hard parts of getting Crucicles to work is the idea of cycle detection. How do you detect in code whether you have a cycle? And there are a couple of ways to do this, but this way is the way that I think is the easiest. Is that we're going to create a structure. I'm going to call it components. And it's going to be a list of lists. So it's going to be an array, but inside it, we can have other arrays. And we'll go through this graph in order by least weight. And our smallest weight is 1. So we look for the edge AB. Is it safe to add this to the graph? I look to see if AB is anywhere in this list. The list is right now empty. And since this edge does not show up in my components list, I will add a component that contains AB. So if neither endpoint is in the list, then append a list containing both endpoints. All right, so then we have added AB to the tree. This edge is now part of my tree. So now look at the next cheapest edge. The next weighted edge is AC. I look in my list to see if AC is in here. A is in here, but C is not. And since one of the edges is in the tree, but not the other one, I'm going to add the missing endpoint onto this list and add AC to my tree. So if one endpoint is in the list, then add the other endpoint to the same list. Add the other endpoint to the same list. Okay, so now we've added AB and we've added AC. I look now for the smallest weight. The smallest weight is 3. And so I look to see if DE is in my component list. Neither endpoint is in the list. And so I have a new component, DE. So DE is not connected to ABC. It's in a separate component because neither D nor E was in my list. And that gives me something to work on here. Okay? All right, so then we look at the next weighted list, and the next is BC, and I look in my components list for BC, and I see that they're in the same component. That means that if I connect B to C, that would finish a cycle. So if both endpoints are in the same component, reject the edge. So we're not going to use this edge as part of my tree. It would complete a cycle. So then we look at the next cheapest edge. That's at weight 5, and that goes from C to E. C is in a component, D is in a component. This is the tricky step. Both endpoints are in my big list, but they're in 2 separate components. That means it's safe to join them together. If both endpoints are in different components, then we merge the components. I'm going to take C and E, and well, that's not what I wanted to do. I wanted to use the eraser and combine these into a single list. And now I will add C and E to my tree. All right, and now look at the last edge. The last edge has a weight of 6, but B and D are now both in the same component, and since both edges are in the same component, I reject the edge, and I have finished the algorithm. The trick is to keep this list of components according to these rules. If neither endpoint is in the list, then we are starting a new component. If one endpoint is in the list, then we add the other endpoint onto the existing component. If both endpoints are in the same component, we reject the edge completely. And if both endpoints are in different components, then we merge those two elements into the same list. I hope that clears that up for you, Jonathan.